United Kingdom Mathematics Trust 2022 Senior Mathematical Challenge problem number 22. How many pairs of integers x and y satisfy the equation square root of x minus square root of x plus 23 equal to 2 root 2 minus y? When we see square root, one idea is to raise both sides to the power of 2. One idea is using or changing variable. These two ideas are important when you see square root. So let's rewrite our equation x minus square root of x plus 23 equal to 2 root 2 minus y. I want to raise it to the power of 2, but I should tell you one important identity, that a plus b squared, should memorize this. Or here we need a minus. A minus b squared is equal to a squared minus 2ab plus b squared. So if you raise both sides to the power of 2, left hand side will be x minus square root of x plus 23 equal to 2 root 2 minus y squared. 2 root 2 minus y squared. So let's rewrite. Left hand side is this x plus 23. Right hand side is 2 root 2 by this, applying this identity, 2 root 2 squared minus 2 times 2 root 2 times y plus y squared. So we can rewrite x minus square root of x plus 23 equal to 2 root 2 squared is 4 times 2, 8, minus 4 root 2 y plus y squared. Okay. So I take all things to, let's do something. I take this to right hand side because I have this square root x plus 23. I want to have one side that contains only this. So I take this to right hand side and I take all these things to left hand side. So it will be x minus 8 is minus 8 plus 4 root 2y plus 4 root 2y, and this one minus y squared equal to, take this to right hand side, x root x plus 20. Now, as I said here, when you see square root, you should use a square root or changing variable. Here, if I want to change variable, I can say I have 4 root 2y. Let's not use that. 4 root 2y, I have minus y squared minus x plus 8 equal x root x plus 23. Okay, so here we will see it's an equation in terms of y and x. So I call this one z to work with these square root. So I say it is 4 root 2y, that's right, minus z equal to square root of x plus 23. Oh, now in next step, I want to see, is it good to raise both sides to the power of 2? What should we do here? We should see if we raise, for example, both sides the power of 2, we can say, okay, 4 root 2 squared, this part. As I said here, a minus b squared. You say 4 root 2 y minus z squared equal to x root x plus 23 squared. So I can write 4 root 2y squared minus 2 times 4 root 2 y z, and pay attention, x and y were integers, so this part that we've considered separately is also integer. So We know y is integer, z is integer, x is integer. So minus 4 root 2y times z plus z squared equal to x plus 23. Now here it's good because we've got rid of many squares, only we have here. So if I write it 4, 4, 16 times 232y squared minus 8 root 2yz plus z squared equal to x plus 23. Look, it is integer, it is integer, it is integer. This part is integer. So we can write root 2 as division of two integers. And it means that root 2 should be a rational number. But we know that root 2 is irrational. If you don't know that, if you want to know the proof, I can prove it for you. You can send message to my WhatsApp number for proving this. So let me rewrite it here in this page. So I can say I take, let me tell you, root 2y here, negative 8 root 2yz here. Take all things except this to right hand side. So if you take all these things except this to right hand side, it will be x plus 23 minus 32y squared minus z squared. So if yz is not 0, because we want to divide by 8yz, yz is not 0, then we divide by 8yz. So or we can say we divide by negative 8yz. So we can conclude yz equal x plus 23 minus 32y squared minus z squared over negative 8yz. Now it is integer over integer. Oh, sorry, not yz, root 2, because we divide by that, root 2 is left. So root 2 is integer over integer, so root 2 is rational number. Contradiction, root 2 is irrational number. So we conclude yz equal to 0. So we conclude y equal to 0 or z equal to 0. Now, let's check these two cases. If y equal to 0, what we have? If z equal to 0, what we have? So here, I replace that y equal to 0, or we can also use, let's use this part, because we've raised to the power of 2, y equal to 0. So x minus 8, if I want to write x minus 8 equal to root x plus 23. And then if I raise the power of 2x squared minus 16x for the formula I told you here, plus 64 equal to x plus 23, x squared minus 17x plus 41 equal to 0. Okay, now I want to use quadratic formula. Let me write quadratic formula here. If you have ax squared plus bx plus c equal to 0, then x equal to negative b plus minus square root of b squared minus 4ac all over 2a. In this case, we can see a is 1, b is negative 17, and c is 41. So x is negative b, negative 17 plus minus square root of negative 17 squared minus 4, a is 1, c is 41. All over 2a. So if we simplify this, let me erase these things to simplify. It will be 17 plus minus 17 squared is 289. Minus 4 times 41 is 4 is 6. All over 2. And we can say, okay, this 17 plus minus square root. 9 minus 4, 5. 8 minus 6, 2. And 1, 2, 5 over 2. So it is not integer. The problem says x and y should be integer. So contradiction, this case is impossible. If z equal to 0, we set z equal to this, y squared minus x plus 8. Y squared minus x plus 8 equal to 0. So let's see the equation we had this part, and z equal to 0. So if we pay attention to this equation, 4 root 2y equal to, because z is 0, this part is 0, so we can get rid of that. 4 root 2y equal to this. Let me write 4 root 2y equal to root x plus 23. If we raise to the power of 2, 4 times 4, 16 times 2, 32, y squared equal to x plus 23. Now we have two important equations. Let me write this one. First one, this one as second one. So first one is y squared minus x plus 8 equal to 0 minus x plus 8 equal to 0. And second equation, 32y squared equal to x plus 23. From here, y squared equal to x minus 8. To replace it here, it will be 32x minus 8 equal to x plus 23. 32x minus 8 times 32, which is 256, equal to x plus 23. If we take this x to left hand side, negative 256 to right hand side, 32x minus x, 31x equal to 256 plus 23, 9, 5 plus 2, 7, 279. And if we divide both sides by 31, x equal to 9. Exactly. Now, if we replace in this equation, in this one, in first identity, first equation, y squared minus 9 plus 8 equal to 0. So y squared equal to 1, and we conclude y is plus minus 1. So let's write. Okay, x is 9 and y equal to plus minus 1. So we want to check that which of them satisfy. If we consider our first equation, root x minus root x plus 23. Root x minus root x plus 23 equal to 2 root 2 minus y. I check both cases. If x equal, let's check x equal to 9. Square root of 9 minus 9 plus 23, 32 equal to 2 root 2 minus y. And if you raise to the power of 2, we can consider two cases. If y equal 1, if y is not 1. So if we raise to the power of 2, the left hand side will be 9 minus root 32. Right hand side will be 2 root 2 squared minus 4 root 2y plus y squared. So 2 root 2 squared is 8. Okay, so 9 here we have 8. 9 minus 8 is 1, I write, and 32, root 32, you can say it is equal to root 16 times root 2, which is 4 root 2. So minus 4 root 2 equal to negative 4 root 2 y plus y squared. If y is negative 1, this part is okay. Y squared in both of cases 1, so you can cancel. So from this, you conclude y should be 1. So the only case for x and y is x equal to 9 and y equal to 1. And the problem says, how many answers do we have? So it is B, and we have one answer. If you want to learn other ideas about square root, about all things in algebra, number theory, combinatorics, geometry, you can send message to my WhatsApp number. It is in the comments and also in the description. Thanks for watching this video. Please don't forget to subscribe, turn on notification, and like the video. Thanks. Bye.